Welcome back to The Explainer, everyone. If you've opened up a science magazine or just scrolled through tech news lately, you've absolutely seen one phrase dominating the conversation: quantum computing. It's kind of become the ultimate modern buzzword, right? But here's the thing, it is not just science fiction anymore. It is literally emerging as one of the most transformative scientific and technological projects of our entire lifetime. So today, we're going to break down exactly what is happening in this wild space, looking at everything from massive global movements all the way down to India's highly strategic national quantum mission.
But before we get into the national strategies, we really have to ask ourselves a pretty fundamental question. Why are massive tech giants like Google and IBM, not to mention virtually every major world government, dumping literal billions of dollars into quantum tech? Well, the answer is that these investments aren't just about making your laptop run a little faster. No way. They are driven by a total fundamental shift in how we process information, how we design materials, and ultimately, how we secure our national and global futures. Nations are going all in because this technology is going to completely redefine global security.
Okay, so let's dive into this. Here is our roadmap for today. 1. The new quantum era. 2. The second quantum revolution. 3. The global quantum race. 4. India's national quantum mission. 5. Transforming the real world. And 6. From consumers to creators. All right, let's kick things off with Section 1, the new quantum era.
If we look back at history, there's a really clear pattern of technological revolutions just completely upending society, the economy, and defense. Think about the 19th century, totally reshaped by the steam engine and electricity. Then the 20th century rolls around, and it's defined by electronics, traditional computing, and the early days of AI. And now, welcome to the 21st century, the era of quantum technology. The reality is, past revolutions completely transformed everything around us: communication, education, industry, the whole shebang. So if we want to stay relevant today, if we want to actually play the game rather than just getting played by it, we have got to deeply understand this quantum shift. It builds on the solid structures of what came before, sure, but it operates on entirely new rules.
Moving right along to Section 2, the second quantum revolution. Now, what's really fascinating here is that quantum physics itself isn't a new concept. In fact, we've actually been living in what you could call quantum 1.0 for decades now. Think about things like transistors, lasers, LEDs, even MRI machines. All of those exist because scientists started figuring out fundamental quantum reality. But what we are talking about today is quantum 2.0. This is a massive shift. We are moving from just observing and understanding quantum consequences to actively controlling and engineering quantum states. We're not just looking at the quantum realm anymore. We are actively manipulating it to build entirely new systems.
And this second quantum revolution is built on a brand new ecosystem supported by 4 foundational pillars. First up, quantum computing, which is all about harnessing quantum mechanics to solve hyper-complex problems that classical binary computers couldn't even dream of touching. Second is quantum communication, which promises ultra-secure networks and data protection. Obviously, absolutely crucial in a world where data is everything. Third, we have quantum sensing. This offers incredibly precise navigation and timing, totally bypassing our reliance on traditional GPS. And finally, quantum materials, which literally involves designing brand new materials with entirely novel properties. These 4 pillars are exactly what nations are racing to master right now.
Which brings us to Section 3, the global quantum race.
Right now, over 30 countries have made quantum technology a massive national priority. It's like this highly complex chessboard of international players. And what's super interesting is that no single country is taking the exact same approach. The USA is taking a huge lead in scalable architectures and software for quantum processors. China, on the flip side, is aggressively pushing quantum communication. They've actually already launched dedicated quantum network satellites to demonstrate highly secure comms. Then you have the European Union playing to its strengths, with collaboration and focusing heavily on open-source software tools. Meanwhile, Japan is leaning into its historic strengths with a massive focus on precision engineering and scalable hardware development. The entire global order is shifting, and everyone is maneuvering to secure their spot.
Let's zoom in a bit for Section 4, India's national quantum mission.
India has officially recognized how vital this sector is, which led directly to the launch of their national quantum mission. And the objective here is just massive. We are not talking about a quick, short-term project to just build a single computer. No, this is a long-term policy effort designed to develop indigenous capabilities right there in India. It's a full-on ecosystem play. The government provides the vision, research institutions pioneer the science, and universities skill up the workforce.
As of right now, this mission involves over 150 researchers spread across 43 different institutions. India's explicit goal here? To transition from being a consumer of technology to becoming a global creator and leader.
To really put this into perspective, let's look at some very specific, concrete targets. First number, 25. India aims to build its very first domestically developed 25-qubit superconducting quantum processor. Hitting that number means crossing a massive technological threshold and proving they have real indigenous hardware capability. Next up, the number 500. And this one brilliantly illustrates a real-world defense application. India has actually set a timeline to establish a 50 to 500 kilometer secure Army drone communication network by April 2026. This is not theoretical physics, folks. This is active, highly secure, real-time defense infrastructure being built using quantum principles, and they are doing it on a highly accelerated time frame.
And finally, 18,000. That is the number of new jobs this specific national ecosystem is expected to generate. Right now, this mission is actively funding 17 different startups, and they're building out everything from computing and communications to those advanced materials we talked about earlier. It is an enormous economic engine, fundamentally designed to build a self-reliant, prosperous foundation for the country's future.
Okay, Section 5, Transforming the Real World.
So, why does all this matter for everyday life? Well, because traditional binary computers really struggle with enormous complexity, quantum technology is going to step in and fill that gap. Think back to the urgency of the COVID-19 pandemic. The whole world was desperately waiting for scientific discovery faster than ever before. Well, quantum computing has the potential to take incredibly complex biological and chemical simulations that would normally take years and shrink them down to mere months. That's a total game changer. Beyond accelerating drug discovery and personalized medicine, we're talking about unbreakable cryptographic security for our financial data, vastly improved climate modeling to predict environmental shifts, and optimizing our energy grids and battery materials. Literally, almost everything around us is going to be significantly impacted by these new capabilities.
Let's wrap up with Section 6, From Consumers to Creators. Look, this technological transition isn't just waiting for the future. It has already started. And because of that, there's an immense need for a skilled workforce. For the students and professionals watching this right now, there is a very clear path forward. The industry desperately needs people to pursue advanced degrees and do that foundational research, but it also really needs folks who can develop quantum algorithms, write the new software, and physically build the hardware that will power these startup ecosystems. Yes, it requires physics, but it also needs software engineers, precision manufacturers, and hungry entrepreneurs. The doors are wide open.
I want to highlight this core philosophy drawn straight from the source material. We have to come out of that consumer mindset. To lead in the quantum era, we must build and innovate. This doesn't just apply to nations like India trying to secure their sovereignty and economy. It applies to all of us individually, too. Relying purely on imported technology is a huge risk. We are facing a critical choice here. We either play the game or we get played by it. We literally cannot afford the risk of merely being technology consumers in the 21st century.
Which leaves us with this final, somewhat provocative thought to end our explainer today. As this second quantum revolution totally reshapes our world, creating entirely new industries, new jobs, new realities, will you just be a consumer of the future, or will you be the one to build it? Seriously, think about where your skills might fit into those 4 pillars we talked about. Thank you so much for joining me on this deep dive. I highly encourage you to go explore this topic further, look into the resources out there, and hey, maybe even take your very first steps into the quantum space. See you next time.